we've seen in our ODE adventure, it's important to do this process in reverse. So in particular, let's try to find a function whose Laplace transform is e of minus 5s times 6 over s to the fourth. And the big giveaway is this e of minus 5s. And for this, I would like to remind you of the formula we just covered that says that the Laplace transform of shift and jump, f of t minus c, uc of t, makes an exponential term pop out. So e of minus cs times L of f of t. But the cool thing is, we can actually read the same formula from right to left. And what it says is e of minus cs, L of f of t. It's the same thing as the Laplace transform of what? Of f of t minus c, uc of t. And then uc of t. Now, again, same formula, but cool new interpretation, because what this says is, if you put an exponential term inside a Laplace transform, what it does, it shifts and jumps the Laplace transform. Okay. And in fact, we can apply it in this example. So e of minus 5s times 6 over s to the fourth. Well, we already have this e of minus cs term. Now we want to write 6 over s to the fourth as a Laplace transform. So e of minus 5s times, well, this smells like a power function. So 3 factorial over s to the fourth, which becomes e of minus 5s. Actually, let me write this as follows, equals e of minus 5s Laplace of tq. And again, using the formula here, we're putting an exponential term inside of the Laplace transform. So what this does, it shifts and jumps the Laplace transform. So it's still something cubed, but t minus 5 cubed u5 of t. So our mystery function, e of minus 5s times 6 over s to the fourth, is the Laplace transform of what? It's the Laplace transform of t minus 5q times u5 of t. T minus 5q times u5 of t. And we've seen why this is important when we solved ODEs, because at some point we had to reveal what the mystery function is, because that's usually our solution. So let's just do one more example with this. So same, but with, so let's do 8 over s squared plus 16, and then e of minus 7s. Again, the thing that gives it away is this e of minus 7s. So e of minus 7s times 8 over s squared plus 16. So we want to write this as a Laplace transform. But that smells a lot like sine or cosine. So e of minus 7s. Okay, we have s squared plus 4 squared. So we want to use this formula a over s squared plus a squared. So let's factor out of 4. Okay, 4 times 2 is 8. So now this becomes e of minus 7s Laplace transform of 2. So I always get that confused, sine or cosine. Well, 4 over s squared plus 4 squared, that's an even function. So we want an odd function here. So sine works. And once again, same thing. We're putting the exponential term inside. So we're shifting and jumping. So L of 2, sine of 4, careful, times t minus 7, and then u17. So our answer is f of t is 2 times sine of 4 times t minus 7, u17. And no, you do not need to expand this out. It's fine as it is.